Determining the optimal quantity and location of flame and gas detectors is critical to ensure the detection system's effectiveness. In the past, detector placement largely relied upon user experiences, common practice, and expert judgment. Though not necessarily incorrect, these approaches typically did not offer a systematic method for assessing flame and gas risks. This has now changed. It is now possible to design consistent and effective fire and gas systems utilizing a technique called fire and gas mapping. Fire and gas mapping provides a framework for evaluating the effectiveness of a detection system based in mathematics rather than judgment. The process begins with defining the facility that is being analyzed. This task is performed either by building a model of the facility using primitive geometric shapes or directly importing an existing 3D CAD model. A hazard assessment, known as grading, is used to set the coverage targets for fire and gas detection. The process of grading ensures that coverage is provided where required and that the targets of the coverage are commensurate to the fire or gas risks for each geographic area. Coverage is defined as the statistical probability that a fire or gas release is detected by the system. Calculating the coverage relies on sophisticated computer algorithms. A 3D model is used to analyze the impact of obstructions on the line of sight of detectors and to evaluate the relative locations of detectors and potential leak sources. Mapping calculations generate both graphical and numerical results and can be performed in one of two ways, geographically or scenario-based. Geographic coverage mapping is used to analyze the fraction of a monitored area where hazards are detectable. The results of geographic mapping are color-coded coverage maps where the coloring represents the number of detectors monitoring any given area. Scenario mapping utilizes fire consequence modeling or gas dispersion modeling as an input. This allows a user to analyze how potential release scenarios overlap with areas where fire and gas leaks are detectable. Performing mapping in this way allows for rich graphical results known as risk maps, which can be used to easily identify weaknesses in the system design. Fire and gas mapping provides unprecedented insight into the effectiveness of fire and gas detection systems. This finally allows designers to answer the questions: how many detectors do I need? Where should they be located? And why? This allows system designs to become more effective, more consistent, and more defensible. With sophisticated fire and gas mapping solutions and technically superior services and support, we continue to advance the safety and efficiency of industrial facilities all across the world.